Okay, this video goes with the example, or this video goes with the student companion, and we're going to do example 1. We want to write a 2-column proof. So 2-column proof, remember, has a statement column and a reason column. And then we try to put statements in logical order that lead from what we're given to what we need to prove. So we need to prove that angle ABD, this is this angle here, this angle ABD, is congruent to angle FBD, which is this angle here. So we want to prove that these two angles are congruent to each other. So let's see what we have here. They're telling us that BD bisects CBE. So here's BD. Change colors. So this BD ray bisects this angle here into these two congruent angles. And then by vertical angles, if we call this angle 1 and angle 2, these two, this angle ABC and angle EBF, are going to be congruent because of vertical angles. So what we have going on is, since these two angles are congruent, and since these two angles are congruent, when we add these two equal pieces together onto each side, we end up with this angle ABD congruent to angle FBE. So that's what needs to come out in the proof. So we're starting with this bisector here, and then also we got the diagram. I'm going to label angle 1 and angle 2, and I'll just call this angle 3 and angle 4 to keep us from having to use the 3 letters when we do the proof. So the first thing we want to say here is that we can go ahead and get this bisector idea in. BD bisects CBE. So ray BD bisects angle CBE. And the reason for that is given. That's our given. Now from the diagram, we can see that angle 1 and angle 2 are vertical angles. And vertical angles are congruent. So we can say angle 1 and angle 2 are congruent. Reason is vertical angles are congruent. So that gives us this angle 1 and angle 2 are congruent to each other. Now we need to use this angle bisector and say that angle 3 and angle 4 are congruent, because of the bisector. And again, this is the congruent sign, sort of like as a shorthand. And these are going to be congruent angles because of the angle bisector. So we can say definition of angle bisector. So we've got angle 1 and angle 2 equal to each other. We've got angle 3 and angle 4 equal to each other. The next step is to show that angle 1 plus angle 3 is the same as angle 2 plus angle 4. So we could say, let's see, angle 1 plus angle 3 equals angle 2 plus angle 4. And that would be angle addition postulate. Now angle 1 and angle 3 is the same thing as angle ABD. So I guess we need a step in here that says that angle 1 plus angle 3 is congruent to angle ABD, and also, comma, angle 2 plus angle 4 are congruent to angle FBD. And that would just be definition of congruent. And then our step 6, to finish this, this ABD is the same as 1 and 3. And this should actually be congruent up here. And this angle 2 and 4 is the same as FBD. So if we substitute from step 5 into step 4, we have angle ABD is congruent to angle FBD. And then the reason is substitution. Remember step 6. And then I usually like to put what steps it went from with 5 to 4. So between steps 5 and 4, we did a substitution. And we ended up proving that angle ABD is congruent to angle FBD. Okay, let's move on. Okay, example 2, we want to apply the vertical angle theorem. So it wants to find the value of x and the measure of each labeled angle. So these two angles we can see are vertical angles. They share the same vertex, and then their sides make up the sides of the other angle. So these two angles need to be congruent to each other. If we call this like saying angle 5 and angle 6, vertical angles says that angle 5 and angle 6 are congruent. vertical angles are congruent. So angle 5 is congruent to angle 6. And then that means that their measure is supposed to be equal. So 6x minus 45 equals 4x plus 5. Okay, we need to get all our x's together. So take away 4x from both sides. 2x's minus 45 is equal to 5. We need to add 45 to both sides. 2x's is equal to 50, which leaves x equal to 25. So we found out that x was 25. We found the value of x, and also they want us to find the measure of each angle. So 6 times x is 150, and 150 take away 45 is 105. So we have 6 times 25 take away 45 gives us 150, take away 45 gives us 105. And since these two angles need to be congruent, or since they are congruent, this is also going to be 105, so we could check it. To do the check, we would have 4 times 25, because we're plugging into this one now, plus 5, and that does equal 100 plus 5, which equals 105. So we know we have the right x because the two angles match. Okay, let's look at B. In B, we got another situation with vertical angles, so these two have to be congruent to each other. So we can say 8x minus 20 is equal to 5x plus 37. And then we need to get our x's together on one side, so take away 5x from both sides. 3x's is minus 20 is equal to 37. Then we need to add 20 to both sides. So 3x's is 57. And 3 times 19 makes 57. So x is going to be 19. So we found out that x was 19. Again, we found the value of x. We got to find the measure of each angle. Now these are both going to be equal, so I really just need to plug it in once. If I could do it again to make sure I got the right answer. So I'm going to do 8 times 19, take away 20, and that's the answer we're looking for. So 8 times 20 would be 160. Since 19 is 1 less, if we do 160 take away 8, we get 152. So 152 take away 20 is going to be the measure of the angle, and that's going to give us 132. So the measure of the angle is 132. If we plug it into this other one, 5 times 19 is 50 plus 45 is 95, plus 37 also gives us 132. So it checks out. Let's move on. Here they want us to write a paragraph proof. Now, paragraph proof, you kind of, if we go back to the other proof that we just did, for example 1, we want to basically get these out in sentence form with 3 or 4 sentences that kind of summarize the reasoning going from this being a bisector, which makes equal angles, along with these equal angles, and them adding together to be equal angles, which does the proof for us. We want to do that in sentence form or in a paragraph. So let's see what we can do with this one. So write a paragraph proof of the congruent complements theorem. Now the congruent complements theorem says that if two angles are complementary to each other, so 2 complementary angles. Now complementary means adds to 90. Complementary. So 2 complementary angles are 2 angles that add to 90 degrees. And if you like, let me do a diagram here like this. Well, it's not really a good diagram, but the congruent complements theorem says that, like, if you have 2 angles, let me do like a picture like this. So you got angle 1, angle 2, angle 3, and angle 4. So let's say that angle 2 and angle 4 are congruent to each other. So if angle 1 and angle 2 and angle 4 are congruent to each other, since these need to add up to 90, 1 and 2, and 3 and 4 also need to add up to 90. If 2 is the same as 4, 1 must be the same as 3. And that's the congruent complements idea. So if you have 2 angles that are both congruent to the same angle or to equal angles, they're congruent to each other. So we want to prove that angle 1 is congruent to angle 3, and we're going to use their diagram that they have here. So they're telling us that angle 1 and angle 2 are complementary. So these 2 angles together make 90 degrees. Now, these complementary angles don't have to be attached. As long as you have 2 angles that add to 90, then they're complementary. So I drew them as, looking like they might be 90-degree angles when they add together, but they don't have to be, as long as they add to 90. And this also tells us that angle 2 and angle 3 add to 90 degrees. So we can say that angle 1 and angle 2 equals 90. Angle 2 and angle 3 equals 90. Since angle 1 and angle 2 equals 90 and angle 2 and angle 3 equals 90, if we take away angle 2 from both sides, we're left with angle 1 equal to angle 3. So let's see if we can get that into words. So we want to use the givens. So we can say like angle 1 and angle 2 are complementary. Also, angle 2 and angle 3 are complementary. Okay, so we got these 2 complementary to each other. That means 1 and 2 add to 90, and 2 and 3 add to 90. By definition, of complementary, measure angle 1 plus measure angle 2 equals 90, and measure angle 2 plus measure angle 3 equals 90. If we subtract measure angle, so since 90 is equal to 90, we can substitute. Let's can substitute. So that measure angle 1 plus measure angle 2 equals measure angle 2 plus measure angle 3. If we subtract measure angle 2 from both sides, we get measure angle, take angle 2, we get measure angle 1 equal to measure angle 3. Which is, and then by definition, so we can say that, so angle 1 is congruent to angle 3 by definition of congruent. Okay, so that's my version of a paragraph proof for this. You may come up with a little bit of a different version, but the idea is that these two angles add to 90, the other two angles add to 90. They both share the same piece between them, so you take that piece away, it leaves angle 1 equal to angle 3. Let's move on. We want to write a 2-column proof for this one, so let's see what they're giving us. Measure angle 4 is 35, so I'm going to go ahead and label it. Now by vertical angles, we know that measure angle 2 is going to be 35. Oops, 35. Measure angle 1 equals measure angle 2 plus measure angle 4. So measure of angle 1 is equal to measure of angle 2 plus measure of angle 4. And we want to show that the measure of angle 3 then is going to be 70 degrees. So let's see what we can do with that. And this is supposed to be a 2-column proof. So that means we need to have a statement, reason, column. And we're going to supply the steps. So always start with the givens. Measure angle 4 equals 35. Measure angle 1 equals measure angle 2 plus measure angle 4. That's given. So we got that marked on the diagram, and let's see what we can do with it. So step 2. So measure angle 1, if we substitute measure angle 1 equals measure angle 2 plus 35 degrees. Okay, now if we look at what's going on with this, we have measure angle 2 plus measure angle 4 equal to measure angle 1. Angle 2 and angle 4 are vertical angles with each other. So we can say that measure of angle 2 equals measure of angle 4, which equals 35 degrees by definition of vertical angles. Vertical angles are congruent. So these two angles are equal to each other, they both got to be 35. If angle 4 is 35, angle 2 has to be 35 because it's a vertical angle. So if we go to this second step here in number 1, measure angle 1 is equal to measure angle 2 plus measure angle 4. So we've got that. Now we're going to substitute 35 for the measure of angle 4, and we're going to substitute 35 for the measure of angle 2. So step 3, we're going to substitute from 2 into 1. So between 2 and 1, we're doing the substitution. And what we're going to then say is that the measure of angle 1 equals measure angle 2, which is 35 degrees, plus the measure of angle 4, which is 35 degrees. So next step, we're going to add these together. So the measure of angle 1 is equal to 70 degrees. That's just addition property. Of equality. Need the addition property to be good enough. So we have angle 1 is equal to 70 degrees. Now angle 1 and angle 3 are vertical angles. Here's the vertex. They're sharing the same side. They're on opposite sides. By vertical angles, these are congruent to each other. So I could say that the measure of angle 3 equals the measure of angle 1, and that would be vertical angles have equal measures. And then our step 6 is basically we've got this done. If measure angle 1 is equal to 70, and since 3 is the same thing as 1, we can just kind of substitute angle 3 in for angle 1, and we have measure of angle 3 equals 70 degrees. And that's just substitution. Property of equality. So substitution would be good enough. And we've got what we were asked to prove. Okay, if we go on to the do you understand and do you know how? How is deductive reasoning used to prove a theorem? We reason in a set of logical steps, towards the conclusion. Which is what we asked to prove, what we need to prove. So look at number 2. Jaden states that based on the congruent supplements theorem, if angle 1 and angle 2 add up to 90, and if 1 and 3 add up to 90, then angle 2 is equal to angle 3. So let's see what's wrong with that. So if 1 and 2 are equal to 90, that means these are complementary angles. And if 1 and 3 are 90, that means these are complementary angles. So what they have between them, between 1 and 2 and 1 and 3, is actually angle 1, which leaves angle 2 congruent to angle 3. Okay, so if you think about this, this is really a little bit of a trick question, because the adding to 90 goes with complements, and he's using supplements, which says that if you have two angles that add to 180 degrees, and if they're both supplementary to the same angle, then that leaves the other two angles equal to each other, just like the complementary one, but it deals with 180 for supplements. And so this reasoning is actually correct if he had used complements. Because if you have measure, we can do this with algebra. Measure angle 1 plus measure angle 2 equals 90. But then also we have that 90 is equal to measure angle 1 plus measure angle 3. So that leaves these connected together, sort of like as a transitive property. If we take measure angle 1 away from both sides, we're left with measure angle 2 equal to measure angle 3, which leaves angle 2 congruent to angle 3 by definition of congruent. But, so that's true. But the mistake is he should have said congruent supplement or congruent complements instead of supplements, because complements means that those two angles, those two sets of angles add to 90, not to 180. The same, there is another one that works for 180 degrees, same exact argument, but that these are the ones where you have two angles that make a straight line, which is the 180 degree supplementary deal. And if one is congruent to the other and they both have to add up to 180, that leaves the other two that are left equal to each other. Okay, let's look at number 3. How's a theorem different from a postulate? A postulate is unproved. It's accepted as true. A theorem is proved. And has to be true. And has to be true. Okay, for this one we can see that they're telling us that angle 2 and angle 3 are complementary. That means these two angles add to 90 degrees. And then angle 2 is the same as this 30 degree angle. And angle 3 is the same as this one, or this angle that's marked 1. So angle 2 and angle 3 add up to 90 because they're complementary. And then we can see that angle 1 and the 30 also need to add up to 90. If we do 90 take away 30, we have angle 1. The measure of angle 1 has to be 60 degrees. So that's basically how we could use the vertical angle theorem. Angle 2, the measure of angle 2 equals 30. Measure angle 1 measure angle 1 plus measure plus 30 degrees equals 90. And then we also have measure angle 2 and measure angle 3 equals 90. So if 2 and 3 are complementary angles, then angle 1 and angle 30 are also complementary angles, because these two are vertical angles and those two are vertical angles. So these must add to 90 if those add to 90. And 90 take away 30 leaves 60. Okay, let's look at the next one. It says use the figure to answer questions 5 through 7. What statement could you write in a proof for measure of ADC? So here's angle ADC. Using the angle addition postulate as a reason. Using the angle addition postulate. So I could say the measure, or we could say that the measure of angle ADB plus the measure of angle BDC equals the measure of angle ADC. And that would be the angle addition postulate. This angle plus this angle makes angle ADC. Okay, I'm going to erase that, and then we'll go to the next one. Let's look at number 6 now. So for number 6, could you use the vertical angles theorem as a reason and a proof to state that the measure of ADC is equal to EFG, or EDG? EDG. So ADC is this angle right here. And if we continue this line on, we get this and this. So this angle and this angle, those two big angles, are vertical angles with each other. So could we use the vertical angles theorem as a reason and a proof to state that the measure of ADC is equal to the measure of EDG, or to state that ADC is congruent to EDG? Yes, we could. We could say that angle ADC and angle EDG are vertical angles. CAL. So get number 7. We're still using the same diagram. Let me erase this off the diagram. We'll switch colors up. Let's move up. Given the measure of ADC is 90, what reason could you give in a proof to state that ADC is equal to HJK? So ADC HJK. Well, if these two angles are 90 degrees, and if HJK is labeled as a right angle, that means it also has a measure of 90 degrees. So since they're both equal to 90 degrees, they're both right angles, all right angles are congruent. So our reason for this could be right angles are congruent. Since this ADC is a right angle, and also HJK is a right angle because it's marked as 1. And we could say that ADC is congruent to HJK because right angles are congruent. Okay, let's look at number 8. So here's the diagram for number 8. So let's see. So the Leaning Tower of Pisa leans at about 4 degrees from the vertical, as shown. Actually, they've pumped concrete and all kinds of stuff in, trying to keep it propped up. Sooner or later, it's going to fall over. It currently leans at an angle about 4 degrees from the vertical, as shown. What equation for the measure of x, the angle it makes in the horizontal, could you use in a proof? Okay, so if originally it was vertical, these two angles together would make 90 degrees. So we call this like angle 1 and call this angle 2. We have measure of angle 1 plus measure angle 2 equals 90. Now, if angle 1 is 4 degrees, then we have 4 degrees plus measure angle 2 equals 90, which leaves taking away 4 from both sides, measure angle 2 is equal to 86 degrees. So what equation for the measure of x, the angle it makes from the horizontal, could you use? We put x in here, so 4 plus x. 4 plus x equals 90 is actually the equation that we could use to figure out. No. Yeah, 4 plus x is 90. Take away 4 from both sides. X is equal to 86.